consider this tree, okay, diagram of a tree, not a great looking tree, fairly skinny. Anyway, from that point there, if we were looking up to the top of that tree, that would be our line of sight, and it's the angle between the horizontal and the line of sight. So we draw in our horizontal, and that angle there, theta, that would be the angle of elevation. Now conversely, the angle of depression is the angle between the horizontal and the line of sight when looking downwards. So there's our cliff, top of the cliff looking down at an object. So there's our line of sight. Let's just complete the right angle triangle. It's the angle between the horizontal and the line of sight. So from where we are, we would need to mark in a horizontal, often not drawn for you, so you'll need to mark that in on most of your diagrams. That is our horizontal, there is our angle theta, that is our angle of depression. Now, there is a connection. See that angle of depression there? That angle there would be theta as well, okay, using the properties of alternate angles on the parallel lines. So that's important that you know that, because quite often you need to mark that angle inside the triangle because you're going to use trigonometry within that triangle. Excellent. Examples now. The first one we have, the angle of elevation of the top of a tree from a point 20 meters from its base is 48 degrees, and we need to find the tree's height correct to 1 decimal place. Now with these ones, it is essential you draw a diagram. So there is our tree. Doesn't have to be a great diagram. Now from a point 20 meters from its base, so there's the point, and that from its base is 20 meters. Let's mark in the information. The angle of elevation is 48 degrees. So there's our line of sight. The angle there, 48 degrees. Now we are asked to find the tree's height. So let's call it H, H for height. And then using trigonometry, some old hags can't always hide their old age. Identify the two sides we're dealing with. The angle is 48 degrees. Directly opposite that is H. So that's our opposite side. The 20 meters is right next to the 48. It's our adjacent side. So using the trig ratio that works with opposite and adjacent, we'll focus on tan. Okay, tan theta equals opposite over adjacent. Our angle is 48 degrees, so we write the tan of 48 degrees. Now it equals the opposite over the adjacent, so H over 20. Right, we've done all our hard work. Next bit is easy. We need to get H by itself. At the moment, it's being divided by that 20, so let's multiply both sides by 20. The 20s on the right side cancel each other out, so excellent. Got the H by itself, and 20 times tan 48, let's write that down, and then on the calculator, we work it out to be 22.2 meters. That's been rounded off to 1 decimal place. That is brilliant. Our second example now. Maria stands at the top of a cliff 85 meters high. Alright, hope she doesn't suffer from a fear of heights. So she stands on the top of a cliff 85 meters high and sees a ship 1.4 kilometers out to sea. Now we need to find the angle of depression between the ship and where Maria is standing. We're going to answer to the nearest minute. Well, as before, let's get a diagram going. There's our cliff. Alright, Maria there is at the top there. Out to sea, alright. There's the water, the ocean. There's our boat. Alright, she sees the boat out there, the ship. Now we're given the cliff as 85 meters high. Let's mark that in. Now the ship is 1.4 kilometers out to sea. Now rather than write 1.4 kilometers, we'll write that as 1400 meters. Alright, given that we've already written the cliff as 85 meters. So let's deal with the same units. Now we are asked to find the angle of depression between the ship and where Maria is standing. Now, that's where she's standing, alright, the angle of depression. If we mark theta there, you would be marking what a lot of people do, alright? That, though, unfortunately for you, would be wrong. Okay, that is not the angle of depression. So I showed you that because that's the common mistake. The angle of depression requires us to put in the horizontal. Right, now that angle there is the correct angle. So make sure angle of depression, you put in the same horizontal, because if you don't, you most generally will make that same mistake I showed you That's theta. That's outside the triangle. It's the same as this angle though, alright? Alternate angle. So let's mark that as theta. Now we can work with the triangle. Some old hags can't always hide their old age. Identifying the two sides from that angle, the 85 metres is directly opposite. It's the opposite side. The 1400 metres is right next to our angle. It's the adjacent side. So we have opposite and adjacent. We're going to be using tan. So we're using tan. The angle is theta, so we write tan theta. Now it equals the opposite over the adjacent. So 85 over the 1400. We're trying to find theta. Alright, tan is involved, but we don't press the tan button just by itself. We must press the inverse tan button or the shift tan. When we do that, we get that theta equals 3.4744. Okay, those numbers continue. That's our decimal answer, but we need to answer to the nearest minute. So changing that to degrees and minutes, we get that therefore theta equals 3 degrees 28 minutes. It's been rounded off to the nearest